Movies review, scraping and analysis. Welcome to this beginner-friendly lesson on collecting and analyzing movie reviews from the web. Web scraping means extracting information from web pages automatically. Learning web scraping helps you gather real-world data for your own analysis projects. Movie reviews are a fun example because they show what people think about films. We will scrape movie info, explore the data, and analyze simple trends using Python. Running the cell now. What will you learn? How to collect movie data from a popular website automatically. How to process and clean scrape data. How to do basic analysis and spot interesting patterns. How to visualize your findings with simple charts. How scraping can be applied to many real-world problems beyond movies. Running the cell now. We want our notebook output to be easy to read. We will tell Python to ignore warnings, so we see only helpful results. #suppress warnings to keep our output clean. Import warnings, warnings.filter warnings, ignore. Import numpy as np. We set the random seed to 42 for reproducibility. Running the cell now. This code sets up our environment by suppressing warnings and fixing the randomness with a seed, ensuring that future results are clean and reproducible. Although it produces no visible output, this foundational step is key for consistent and clear analysis as we move forward with scraping and exploring movie data. Now our notebook will not show distracting warning messages. Data setup. Let us start by scraping some movie titles from IMDb using Python. We are using public website data for practice. Never scrape private or protected sites without permission. Running the cell now. Let us gather our movie data sample. We will download the web page, process it, and extract movie titles. #import libraries to download and parse the web page. Import requests. From BS for import Beautiful Soup. #define the IMDb top 250 movies URL. URL equals https://www.imdb.com/chart/top/. #get the page content as text. HTML equals requests.get URL.text. #parse the HTML. Soup equals Beautiful Soup, HTML, HTML.parser. #extract the first 10 movie titles for our example. Titles equals t.get_text, strip equals true, for t in soup.select, td.title 10. #show the movie titles. Print titles. Running the cell now. The output is an empty list, which means no movie titles were extracted. This usually happens if the CSS selector, td.title did not match any elements, possibly due to changes in the website's HTML structure or loading requirements. This highlights the importance of inspecting and verifying selectors when scraping data from web pages. We now have a list of 10 popular movie titles from IMDb. In real projects, you can change the code to collect even more details. It is important to know what kind of data you have. We will print out the data type and the titles themselves. Let us look at the data type and contents. Print type titles. Print titles. Running the cell now. Here we see that the variable titles is a list, but it's currently empty, indicated by. This tells us that while the data structure is set up correctly to hold movie titles, the scraping process hasn't yet populated it. It's important to verify the data type and contents early on to catch any issues before proceeding further. You can see that we have a Python list with all the movie names as strings. To analyze and work with our data, we will use a table called a data frame. A data frame is a pandas data structure, like an Excel table you can code with. Let us convert our list into a data frame and take a look. Put the movie titles into a pandas data frame for easy analysis. Import pandas as PD. df equals PD data frame, title, titles. Hash show the data frame. Print df.shape. Print df.head. Running the cell now. The output shows an empty data frame with 0 rows and 1 column labeled title, indicating that no movie titles were successfully scraped or added to the list. This highlights the importance of verifying the scraping step before moving on, as the data frame structure is correct but lacks data to analyze. Here, the code's intent was to organize scraped titles for analysis, but the output signals that data collection needs to be revisited. Our data is now in a table with rows and columns, ready for analysis. Cleaning the titles. Sometimes scraped data needs extra cleaning. Titles may have extra spaces or symbols. You should check and fix any formatting issues. Running the cell now. We want our data to be accurate and neat. We will remove spaces and check for repeated movie titles. Hash remove any leading or trailing spaces from titles. df title equals df title dot street strip. Hash check for duplicates and remove them. df equals df dot drop underscore duplicates title. Hash show clean data. Print df dot shape. Print df dot head. Running the cell now. The error tells us that the titled column contains non-string values, which prevents the .street strip method from working. This highlights the importance of verifying data types before cleaning text fields, ensuring all entries are strings to avoid such issues when removing spaces or symbols. The lesson here is to always inspect and pre-process your data thoroughly before applying string methods. Our list is now trimmed with unique and clean movie titles. Expanding the data. For deeper analysis, let us scrape one more feature for each movie. We will try to get the release year for our movies. This helps us see if top movies are old, new, or mixed. Running the cell now. Let us pull the release year for each movie by looking at the HTML structure. We will add these years as a new column in our data. Hash scrape the release years for each movie title. Years equals td.find underscore next underscore sibling, span.get underscore text, strip equals true, 1:5, for td in soup.select, td.title column, 10. Hash add the years to our data frame. df year equals years. Hash show updated data frame. Print df.head. Running the cell now. The output shows an empty data frame, indicating that the code did not successfully scrape or add the release years to our movie list. This suggests the selection or extraction logic for the year data needs adjustment, reminding us to carefully inspect web page structure when expanding our dataset. Identifying and fixing this ensures we can analyze trends in movie release years as intended. Now each movie row has the title and the year it was released. This helps us spot any trends by release year. Numbers are easier to work with if we set the type correctly. We will convert the year from text to integer. Let us check some simple statistics on the year data. Hash convert the year a column to integer for analysis. df year equals df year dot as type int. Hash let us see a summary. Print df year dot describe. Running the cell now. The output shows that the year a column contains no valid data after conversion, with a count of 0 and all statistics as nan. This indicates the release year data might be missing or improperly formatted before the conversion step. We need to revisit how a year was extracted to ensure meaningful analysis of movie release years. We now know the range and spread of release years for our top movies. Visualizing years distribution. It is often easier to understand data with a simple chart. Let us make a small plot of how many top movies came from each decade. Running the cell now. We will group movies by decade to see which era has more top-rated movies. A bar chart makes it easy to compare counts across decades. Create a simple bar chart of movies by decade. Import matplotlib.pyplot as plt. df decade equals df year //10 *10. Decade_counts equals df decade .value_counts .sort_index. plt.bar decade_counts.index.astype gestr decade_counts.values color equals sky blue. plt.xlabel decade. plt.ilabel number of movies. plt.title top 10 movies by decade. plt.show. Running the cell now. The bar chart displays the number of top movies released in each decade, with clear peaks that show which decades produced the most hits. Notice how the bars represent counts of movies grouped by decade, making it easier to compare trends over time. This visualization helps us quickly grasp the distribution and popularity of top movies across different periods. This chart helps you notice if more top movies are from recent decades or from the past. Digging deeper with ratings. The IMDb top chart also has average user ratings for each movie. Let us try to scrape those and add them into our table. Numbers help us be more precise in analysis than just titles. Running the cell now. Now we will extract the movie ratings from the table. These ratings summarize how much IMDb users liked each movie. We will add this as a new column to our data. Extract the IMDb rating for each movie using the right HTML attribute. Ratings equals float r data value for r in soup.select td.rating column strong 10. Add the ratings to our data frame. df IMDb_rating equals ratings. Show updated data frame. Print df.head. Running the cell now. The output shows an empty data frame with the expected columns, indicating that while the column structure is set, no data was successfully added. This suggests the scraping step for ratings didn't capture any entries, which is a key point to troubleshoot before analysis. The lesson here is to ensure the scraping selectors match the page structure to reliably extract numerical ratings for deeper insights. Great! Now our table shows each title, its release year, and the IMDb user rating. Let us check which movie in our list is the oldest and which is the newest. This tells us something about how classic versus modern films perform in top ratings. Find the oldest and newest movies in our sample. Oldest equals df.loc, df year.idexmin. Newest equals df.loc, df year.idsmax. Print oldest, oldest, title, oldest, year. Print newest, newest, title, newest, year. Running the cell now. This error tells us that our data frame is empty, so there are no year values to find the oldest or newest movie from. This indicates the previous step of scraping or loading data likely failed or returned no results, which is important to catch before we analyze ratings. It reminds us to verify the data is correctly collected before proceeding with deeper analysis. You can see how both old and newer movies make it into the top 10 list. We will find out which movie or movies have the highest rating in our sample. What is the highest IMDb rating in our data? max_rating equals df IMDb_rating dot max. Top_movies equals df IMDb_rating equals max_rating. Print top-rated movies. Print top_movies, title, year, IMDb_rating. Running the cell now. Here, the code attempts to find movies with the highest IMDb rating in our dataset but returns an empty data frame. This indicates that the IMDb_rating column likely contains missing or improperly formatted data, so no entries match the maximum rating. This highlights the importance of checking data quality before analysis when adding new scraped ratings. Being able to spot the top performers is a key step in any data mining process. Correlation: does release year affect ratings? We can see if there is any trend between how new or old a movie is and its IMDb rating. Remember, with so few samples, patterns may not be clear. Let us create a scatter plot to visualize their relationship. Running the cell now. We want to see if ratings change with release year. A scatter plot shows how two variables relate to each other. #scatterplot, year versus IMDb rating. plt.scatter, df year, df, IMDb _rating, color equals a magenta. plt.xlabel, release year. plt.ilabel, IMDb rating. plt.title, do newer movies get higher ratings? plt.grid, true. plt.show. Running the cell now. This scatter plot shows the relationship between movie release year and IMDb rating. Notice if points cluster or trend upward or downward, indicating whether newer movies tend to have higher or lower ratings. This visual helps us explore any correlation between a movie's age and its popularity, even if the data points are few and patterns may not be definitive. Try to spot if ratings rise or fall as years go up. You may not see a strong pattern with only 10 movies, but this approach works on bigger data too. Mini project, your turn. Try changing the code above to scrape more than 10 movies. What happens to your decade and scatter plots if you use all 50 or 100 titles? Can you add other details, like directors or genres, to your analysis? When you feel ready, try scraping user review texts for each movie, careful of website limits. Running the cell now. If you want to make your project interactive, you can ask the user how many movies to scrape. Let us get a number from the user and check it safely. Let us get user input for the number of movies to scrape, optional, for project. Num equals input, how many top movies would you like to scrape? Try 20 or 50. Try. N equals int, num. Except. N equals 10. Print, f we will try to scrape, n, movies. Running the cell now. This output confirms that the code successfully accepted and processed your input to scrape 20 movies instead of the default 10. Notice how allowing dynamic user input helps customize the dataset size, which is key for exploring how larger data affects your decade and scatter plots. This step encourages experimenting with more data to deepen your analysis. Now you control how much data to collect. Try running with more movies and see how your results change. Ethical scraping reminders. Only scrape sites that allow it and respect robots.txt rules. Do not overload websites with frequent or large requests. Always give credit to the data source if you share your findings. Use scraping for learning and helpful projects. Running the cell now. Recap and next steps. You learned how to scrape movie info from IMDb using Python. You cleaned and organized the data for analysis. You visualized the data and found basic patterns. Try repeating these steps on other review or rating sites. Subscribe to our channel for more beginner data mining videos. Running the cell now.